our next speaker, Daniel, is going to be talking to us about water security, process impact, and solutions. And he is going to be also shedding the light on some of those very important to address some of the important variables. So right now, I'm going to be giving Daniel, I'm going to give you the presenter privileges, and then you can share your screen while I make your introduction. So Daniel, who is going to be our next speaker, he is Associate Professor of Course and Agriculture Engineering. I would like to ask all to mute yourself, please, if you are not presenting. So Daniel is Associate Professor of Bioresource and Agriculture Engineering Department, California Polytechnic State University in San Luis Obispo. Dan has 25 years of experience working in irrigation industry on projects in the Western U.S. and internationally as well. He teaches irrigation courses at Cal Poly, including irrigation system design and management, irrigation water and salinity management, pump and well design, and irrigation project district design and modernization. He teaches short courses on industry professionals, including drip irrigation design, irrigation scheduling, drip irrigation system evaluation. He specializes in the irrigation project modernization and farm water management, evaluation of basin watershed and field level evapotranspiration, remote sensing, flow measurement, nutrient and salinity management, and agriculture-based energy use. The floor is yours.
Thank you, Hisham. I'm going to talk a little bit about water security, process impact, and solutions. Some of the stuff that's going on in California and the U.S. right now. That I thought would be you'd find interesting. A couple pictures, some of the elements that we have in California, and then some. We work a lot at the ITRC, at the Irrigation Training and Research Center, with irrigation districts, irrigation projects, and infrastructure and modernization. That's not the topic this year. I talked a little bit more about that last year in our discussion. But the overview today is going to be, what we're going to look at is how to attain real water security. So I think from Mark's perspective, we're going to drill down. I thought he did a great job. We're going to drill down a little bit more and talk a little bit more about I think the inner workings of how water security can be attained. Some of the common misunderstandings from those that aren't familiar with let's say irrigation and irrigation efficiencies and water efficiency, and then how to really come up with the solutions and understanding what the fallout or the results might be, and then discuss a little bit about how to maximize the water that's available, a little bit. Something similar, but not as much detail, obviously, as was just presented. So let's jump in. Attaining water security, and in California, in 2014, we passed a law. It's called the Sustainable Groundwater Management Act, and that limits how much groundwater we can use in our basins throughout the state. And so previous to this, we could pump groundwater as much as we wanted. Now we can't. You can't use the groundwater as a supply. You can only use what would naturally recharge as a supply source. You can carry, say, water you store from year to year, but you can't use the groundwater as a supply, which really creates bounds. And I'll talk about this. Puts the bounds on the subbasins, what we call a subbasin, and how much water they can actually consume. And we'll talk a little bit about consumption. So in California, and this is the same anywhere because hydrology is hydrology, doesn't matter where you're at, the maximum consumption, and I don't like to use the word use because it's misleading. Consumption is very, very straightforward. It is how much plants use or how much water might go to a salt sink. It can't be, you can't recover it, basically. Our max consumption is the amount of surface water available in a region, plus the rainfall, plus the natural groundwater recharge. And so from a sustainability standpoint, if we want to be sustainable in a sub-basin, meaning that we can survive for long term, we have to stay within these bounds. And I'll talk a little bit more about that here in a little bit. So just real quickly, what does that mean? This is one of our sub-basins. This is the average groundwater level in one of the sub-basins in 1964. If we kind of start there and move towards the mid-2000s, you can see a continuous decline in groundwater storage, about 6 million acre-feet decline in this one sub-basin. What this law is going to do by 2040 is flatten this out so that it's no longer, it might go up and down, but it's not going to continually drop over time. Okay, so what are some of the misunderstandings? One is that the improving efficiency can somehow save water. And we have to be careful with that. In California, we have what's called conjunctive use, which means that we have surface water and groundwater supplies. And so if we have surface water, we apply that water and it's not at 100% efficiency, where does that water go? Well, it goes to recharge the groundwater, and we pump that later on. So before you can say you're going to save water, you first must define how you're losing it. And therefore, you need to understand the hydrology of the system. So let's say in many areas of the world that use both groundwater and surface water, we have water coming into our irrigated agriculture, and the losses are either run off back to the river, which someone else downstream will use now, or deep percolation to the groundwater. Okay, so which we're going to pump back up later on, and someone else will use it. So our basin efficiency is very, very high. Our basin efficiency is near 100% in most of the Central Valley of California, which is our biggest agriculture area. So how do you save water through innovation? You don't. There's no way to save water. We have to come up with other solutions. How do we stay within the bounds? So let's talk a little bit about the security aspect. We have our total water supply here, and that is the destinations of those water supplies are consumptive use, which is in California at least, and in most of the world is evapotranspiration, how much the plants are using. And both the environment, ecology, agriculture, municipal and industrial uses, how much is being consumed. The wastewater is typically goes back to the river and someone else's supply, or it may be used within your basin. And then, so we have inflows and outflows with the groundwater. Our consumptive use, or our bounds now of a sustainable water supply is just what we have available in terms of surface water coming in and that sustainable groundwater supply and precipitation. So we've really limited and put a boundary on how much water we can actually consume. And once you do that, if you know how much plants use, you can figure out how much agriculture you can produce. And what we're doing at Cal Poly, one of my projects is the remote sensing of actual evapotranspiration. Similar to Alexi, it's a surface energy balance, but I think ours is better. Ours is different in that we don't do large scale. So Alexi's looking worldwide. We're looking more localized. So I review every image. And you can see you can get down to these fields are 20 hectares. The smaller ones might be 5 or 10 hectares, just to give you some ideas of scale. Blue is high ET and yellow is low ET. And then we're combining that with surface information within our irrigation projects to find out what the net groundwater consumption is. We're actually not metering groundwater. We're using this instead of metering groundwater because the meter gives us gross how much we applied, but that's not how much was actually consumed. What we want to know is consumption, not application. Because you start to, when people start saying, well, you're going to save 50% of your water, 50% of applied water savings on this field, it means nothing. Because that water would have just goes down and recharges the groundwater. right? So someone else uses it within the basin. There is no savings by innovative technologies or improving irrigation efficiency. The savings is that maybe in quality, groundwater quality, or water quality in general, or efficient energy use, but not in quantity. So you got to be real careful when people start to claim savings, because what's really going to happen in order to meet and stay within our bounds is we're going to go from irrigated agriculture. These are some onions that we grow in California, to non-irrigated. We're going to have lots of land fallowing. Approximately 600,000 hectares in California out of 3.7 million hectares will be fallowed. So we currently irrigate 3.7 million hectares. It's one of the most, it is the most productive agricultural region in the United States, and we're going to, cut it down by basically a fifth due to this law. But will be sustainable, and that's part of water security is sustainability. One thing, it's not going to be continuous. These are our irrigation projects, and just about a little less than a quarter of our area. We have the blues are irrigation projects that have sufficient surface water supplies. They will not be impacted by this law. If it's yellow and red, that's where the fallowing is going to occur. And if it's red, those areas are going to get hit even harder. They have no surface water supplies, so they have to rely on groundwater, which is no longer available. So we need to start looking at locally what's going to happen. Solutions, there really is no solutions, just mitigation. We can talk about desalinization, but we're talking about a lot of water, a lot. And we don't have a lot of saline drainage water. We do have a lot of ocean, but it's not cost effective to irrigate with desaled ocean water. So just to kind of wrap this up, what are our solutions? Like I said, it's not really a solution, but a mitigation to try to improve on or to have less of an impact economically. We need to look at producing more crop per acre foot of water, or per unit of water that's applied. And so this is just some images or some graphs of yield versus evapotranspiration for about 260 almond orchards in a certain part of California. And we have a lot of almonds. It's local, so they're all about in the same local general area. Soil types are pretty similar. Irrigation types are similar. What I want you to notice is that, and the ages are similar, is that some of these fields are producing very high yields with much less water than others. And conversely, some fields are producing very low yields and using a lot of water. And so what I'm proposing is a shift in agronomic research and irrigation research away from traditional controlled research to more systems-based approach. What's going on in these orchards that is creating higher yields with lower water use? And how can we pass that information on to other growers so that we can improve our yields with less water? Internationally, every area at some point will have to conduct similar laws. We can't continue to mine groundwater unlimitedly, or from an unlimited perspective. Surface water is already overutilized. Irrigation efficiency is not going to solve the problem in most areas. It will in areas that have high water table saline water, where you have drainage issues, where the inefficiency goes to a saline high water table. Irrigation efficiency will have a dramatic impact. Irrigation efficiency will also have an impact on yield, right? So these fields are doing well because they're efficient in terms of how the water is applied, how fertilizers are applied through the irrigation systems. So these were all drip systems, but it's not going to solve, it's not going to create water. It's not going to save water. And so these are how we're going to move on into the future. Thank you for your time, and I look forward to your questions.
Thank you so much, Daniel, for your presentation. Really appreciate it. We are 1 hour down in our session, and we still have 1 more hour. We have 2 more presenters, and then we are going to be opening the floor for discussion and for questions. I encourage all the attendees to start posting your questions, and I'm assigning them as we speak in that session to different presenters.